Hey there, IT 140 students. So in this recording, we are going to talk about functions in Python. So first thing is that you've had some math classes back in the day, and I want to relate the idea of a function to operations in mathematics. You've taken two values, added them together, and you've gotten the sum in return. So keep in mind that the same idea is going to apply in programming. We want to encapsulate how to perform some actions. Some functions may return a value, like doing addition. Okay, in mathematics addition, we get a sum back. But we might write a function that just performs some repeated actions that we want to utilize over and over again. Okay, so keep in mind what we're trying to do is encapsulate functionality that can be performed multiple times. All right, so let's talk about some definitions here. So they say that a function is a named series of statements. Same idea that I'm talking about. I want to encapsulate some functionality. So the function definition consists of the name and a block of statements. So we might have a function called print pizza area, and so to define it, we have to have the def keyword, the name of the function, so this is the name of our function, and then you see open and close parentheses and a colon. Whatever statements are associated with this function are then going to be indented afterwards, just like an if statement, while loop, and so forth. So this is the definition. So if I come down here, we can see here is the definition of this print pizza area. We've got the value for pi. We're going to have a diameter of 12. So to calculate the area of a pizza, we have to have the radius. So that's half the diameter. And the area is pi times the radius squared. They're just multiplying radius by itself. That's fine. They could have used the math pow function. Any of that is fine. So they've got the area of the pizza right here. And then they've got this called print the pizza area. So they're going to go ahead and print it out. Again, you've seen these things right here, a print statement. So this is the encapsulation of the print pizza area method. Again, note that it's got the def keyword. We have the name of it. We have to have open and close parentheses, a colon, and then the statements that are associated with it are indented. And then calling it is we use the name of the function. So right here, later on, if we wanted to, we just call it by saying print pizza area, and the execution in our code is going to jump up into this method, perform these actions, and then return to where we were and continue on in the code. Oh, by the way, note that they are using the snake case format here. So just like in our code guidelines announcement, we snake case it. Everything's lowercase. New words start with lowercase letters, and we have underscores in between them. Let's see what else they have in here. I think that's it. Okay. So the next section, what we might want to do is have a method that is more usable. And what I mean by that is if I come back up here, this relies on the diameter of the pizza being 12 inches probably, okay? So this is hard coded in here, and I can only create the area of a pizza that has a diameter of 12. What would it take to have a diameter of say 15 or 18 to change that? So we can provide what's called a parameter to our function, which will be an input to the function. So you can see down here, we've come and said, define print pizza area, same exact thing, but now this is a parameter. We've said, when I call this method, I have to provide it the diameter of the pizza. So this is a contract. To use this method, I need to provide a diameter. And so the code got changed where instead of having in the diameter being 12 hard-coded, now I can take this parameter value, I can manipulate the radius by taking the diameter divided by 2. And now when I call it, see, I can provide it 12, I can provide it 16, and I can provide any diameter I want to this method, okay? So now I've got a method that I can use for any size pizza as long as I know the diameter. Oh, by the way, if I call it without providing this parameter, that's going to be a syntax error. Your code is not going to run. So you have to keep in mind, you have to look at the function and it's saying, give me a diameter. Got it. Sure. Here you go. 12 is the diameter. Where might we get this diameter from? It could be a user input. We might have a program that says, enter in the diameter of the pizza, we grab it, we then pass it to our method. In fact, it might look something like this. Hang on one second. So again, let's assume that we have this print pizza area method defined. And so then in the main code, we might have something like this. Diameter equals int input enter pizza diameter in inches. Great. And then I can come down here and I go print pizza area and I provide it the diameter. Okay. Now, one thing that new programmers kind of get hung up on sometimes is that this parameter, this is an input and a variable available inside this method right here. Okay. I don't necessarily need to have it called the same thing. So while it's called pizza diameter for the method, I could define a variable just called diameter, pass it to it, or if I wanted to, I could have called it pizza diameter as well. And either of those are going to be just fine. Okay, we'll talk a little bit more about the details of manipulating possibly these parameter values, but we'll talk about that in a different section. All right, so the parameter is the input defined in the function. The value provided to the function when it's called is called an argument. So this right here is an argument that's being passed to the function. This is the actual value that we're passing. So keep in mind parameters when you define the function. Argument is when you pass the value to the function, okay? We could have multiple parameters. So now instead of just calculating the area of the pizza, we want the volume of the pizza. So to calculate volume, you need to know the diameter, and then volume is always based on a height. So now we've got two parameters. They have a pizza radius, so they're going to, again, get the diameter divided by 2. They're going to calculate the area, and then volume is always area times height. So this is going to work just fine. In fact, we could actually clean this up. So let me copy this, and really this should be cleaned up like this. Assuming that we have the pizza area method defined, wouldn't it be great that we just replace this code right here with calculate the area? That would be a real nice to have, and we'll see how we can improve that here in a little bit. Okay, so we'll come back to that. We'll revisit that as we see how we can create a better instance of this method. Again, same idea applies. So we can have as many parameters as we want. Keep in mind, when you call this method, you need to provide the parameters in the order. First value is the diameter, second value is the height. If you get those reversed, so if I reverse the order of these, then this calculation is not going to be correct. So this is a contract that you have to adhere by. We will see in a different section how we could use the named version, but for now, just keep in mind, you have to follow the order that these are in. Okay, next section. So here we talk about the idea of having a function that's going to not only perform work, so if I go back here, these methods performed work. So they calculated the volume and then displayed the output. So that just performs work. Here, we not only want to perform work, but we're going to return back a value. Again, I lead it back into, think about a function in mathematics. When I take value 1 plus value 2, it returns back a sum, okay? So here, we're going to define a function called compute square. We're going to give it a number to square. And then the arithmetic's really simple. To square a number, it's just the number times itself. And then the powerful thing here is we have a return statement. So what this is going to do is it's going to calculate what this value is, and then it's going to return it back to where it was called. So anytime I have a function that has a return statement, it's going to be used in an assignment statement, okay? Or potentially it could be used in an if check or a while check. We'll talk about that later on. So anytime I have a function that's going to return a value, its value is going to be used. So we have compute square, they're going to give it a value. Again, in this case, it could be 7. And then this will jump into here. It's going to say, yep, 7 times 7, that's 49. That gets returned back from this function. So then it gets assigned to the variable num squared, and that's why we get this to display out. 7 squared is 49. Okay, so always keep in mind a return statement returns a value back to the caller. My ideal situation is that you only have one return statement, and it's always going to be the very last statement. All right, let's see what else we got in here as far as returns. Let's see if they take care of the pizza. Not yet. They do give us a nice function that we want to convert centimeters. We want to convert as what? Centimeters. What is this one doing? We're going to convert a height in feet and inches to centimeters. So we provide the feet and inches of a measurement. So we get the total inches. So if, think of your height. If you're 5 feet, whatever. So in inches, that's 5 feet times 12. So that's 60 inches plus however many more inches you are. So if you're 5'9", this is 60 plus 9. So you're 69 total inches. And then we have a conversion factor. It's 2.54 centimeters per inch. So we multiply our total inches and that value, and we return that back. So in this case, if I'm 6'4", I'm going to get back. It will calculate how many centimeters I am, and is going to spit that back out right here. Again, have a single return statement. So this is kind of talking about that idea of the area situation. So if I come back, let's consider the case of this print pizza volume here. Really, I would rather have this be a calculate pizza volume. And I'm not going to have print inside this method right here. I don't think that makes any sense because now I am restricted to only using this in a console application. But to calculate the pizza volume, kind of similar idea here. Let's assume that this is define the pizza area because the code's going to be the same. We're going to have a diameter. We have our pi value. We calculate the area of the pizza. That's all this would do right here. And we return that back. So now, where they have pizza area, I could call the calculate pizza area method, and I just give it the diameter. So that would jump into a method that returns our area. And then to get the volume, it's the area times the height. Again, this would calculate it for me using that function. And then we return the pizza volume. So this is a way better implementation. I don't like that they had the printing handled inside this method. Methods should perform one action, okay? Just one action. I want it to calculate the volume. Perfect. And then when I use it, I could have a variable like volume, calc pizza volume 12, and we'll make it a real deep dish pizza here. So I pass it in a diameter of 12, a height of 4, and so now I get back the volume, and let's do this. Let's just clean it up a little bit more. Diameter equals, we'll just do the old int input, enter diameter. The height is a int input. We could have made those floats, but that's okay. We'll just use integers. Enter height. And so now, instead of hard coding in 12 and 4, I can give it the diameter, I can give it the height. Let's get that spelled right. And so now I can use diameter, print my output height, and then volumes calculated, and there it is. So this is going to work just fine. I've got a separation of functionality where this is only calculating the volume, and then I can print it out like in my main method here, okay? Keep in mind, Python, in terms of variables, lets data types be dynamic. And what that means is they can be anything. Ideally, if I'm creating a calculate pizza volume method, okay, so ideal if I'm creating a calculate pizza volume method, this should be some kind of integer or float type value. It should not be a string or a character, right? Makes no sense that if I try to provide this a character, can you divide a character by 2? Well, yeah, it'll treat it as a number value, but it's not going to make any sense. Even better is a string. So I pass in a string. Let's say that I pass in the word happy. So if I pass in happy, can I divide that by 2? Absolutely not. Makes 0 sense. So this function is not going to work. So you need to keep in mind that Python lets data types be any type. So I could have an add method here, and I could call it with 5 comma 7, and Python's going to be smart enough that says, all right, you've given me 5, you've given me 7. I know that those are integer values, and I can add those. You're going to get a result of 12. Okay. However, I could also pass it Torah and Bora. I can give it 2 strings. And in this case, when I give it 2 strings, it's going to concatenate those because that is an operation available to strings. So I would get Torah, no space, Bora, and it's going to be output like that. So can you create a function like this to handle the same operation? Sure, absolutely. Um, Ideally, do you really want to have a function that can handle multiple types of values? Probably not. But keep in mind, what would be really bad is if you pass in the wrong data type, and then inside this method, you're expecting integer values or double values, and you get in a string. It's just not going to work, okay? So formally, the idea here is Python is dynamically typed. You can pass in, you can use variables of any type. It may not work though, but in other programming languages, say C, C++, Java, we use what are called static typing, where the variables and the types have to be the exact types. So if I want a method in Python or C++, I have to specify this is going to be an integer value, and I can only pass it an int. If I pass it in something else that's not an integer, it's going to crap out, okay? All right, so we continue on. So now that we've talked about functions, writing them, so here, again, why do we want to define functions? First thing they mention is it improves program readability. Um, I can come through this little script right here, and I can see I've got a diameter, I've got a height. Those are inputs. I'm reading in from the console. The volume, oh, hey, look, I'm calculating pizza volume. Then I just have to go see where it's defined. And if I'm using an IDE or even like a simple text editor like Notepad++ here, I can see, oh, calculate pizza volume, here it is. And oh yeah, this just encapsulates the volume calculation, and great. So I don't need all of that busyness to be displayed right here when I'm looking at the main script. So that's one idea, is it makes my program more readable. So I don't need to guess on, so what actions are being performed here? Why are they doing this? The function will encapsulate. So great here, I've got steps to feet, so they got a conversion, so I can understand what that's doing. We can convert the number of steps to calories, great. So I can understand this. I'm assuming there's a calculation that was provided. All good. So that's improved readability. Second thing is we get to make modular program development. We can create our program in chunks. We can avoid writing repeated code. So again, same idea. We've got the pizza calculating the area. So I could have pizza diameter 1 that's got a 12-inch diameter, another pizza's got a 14-inch diameter, and look, this code right here is the exact same as this code right here. So no sense in copying and pasting. We can define our function. We can have a diameter 1, a diameter 2, great. And then ultimately we want the total pizza area, so I can calculate pizza area 1, calculate pizza area 2, add them together, and then I can print my output. Oh, by the way, they're adhering to my rule of we should not be performing any arithmetic in a print statement, okay? So I like that they did that. So again, the advantages of functions is I can create things that are reusable. So I can reuse this every single time I need it. And again, it does make the code more readable. In 5.6, they talk about function stubs, and I just want to take a real quick second here. So you may be creating a program. You know that you need a function for steps to feet, converting steps to calories. But what you might not do is you might not know the implementation of it. So a function stub is where you just define the function, and then here they're providing the pass keyword, which just says, I haven't implemented this yet. This is something I need to come back and do. In fact, what we should really do is when I define it, I should put in a comment to do my initials, the date, so today is 6-3, find out algorithm from my team lead, blah, blah, blah. Make sure that it gets denoted as a to-do. Otherwise, it may not ever get implemented. And oh, by the way, I don't like how they just use the pass keyword. All this does is when it gets called here, so steps to calories, it just wouldn't do anything. I would rather have a little bit more meaningful value. So for instance, what I might do instead of using a pass here is I might return -1. The reason I'm doing -1 here is if I convert my number of steps to feet, or if I convert number of steps to calories, excuse me, a negative number would not be valid here. So if I then start seeing, oh my goodness gracious, I'm getting in -1, then that's a real key to me that, oops, I got something wrong. And then when I go look in my code, I'm like, oh yeah, hey, look, I'm returning -1, and I've got a to-do telling me that I need to implement this functionality. Okay, so again, they even hollered about that right there. As we move to the next section here, so consider a function as just a small script of functionality. So if you have a function that needs to have some kind of conditional statement based on a price, so we might have some kind of fee that's associated with a price, you can have decision structures in here. You can have loops in here, okay? So whatever logic needs to go with this calculation, this function, you can perform that. This is no different than a script anywhere else. And again, you can call multiple functions. You can have functions with loops. Again, anything goes. Just make sure that whatever action you're performing is correct in here. And so last section we'll talk about in this part of the recording, some common errors. So copy paste is always a common error in any kind of code. You write this function right here, great, you copy it, you come over here to the side, you paste it. We're going to create Fahrenheit to Celsius. So you go Fahrenheit to Celsius. You call this variable Fahrenheit. You do whatever work, and that's, let me copy that right there. So oh, hey, that's how I implement this, and I do that, and then I move on. Well, this method right here, we forgot to change the return statement. So return the variable Celsius, okay? So common mistake is copying and pasting and not updating all of the code. Not having a return statement. So I've got something here and it does the work, and so we call convert Fahrenheit to Celsius. So right now it's like 70 degrees outside. And so then I do a print statement converted and I get an error. I don't get anything, and that's because this method does not return anything. My rule of thumb is this: as you create your function, before you write the code, if you know that this is going to be returning a value, I'm going to come back here and return the variable. So as I write my code, I know that I'm going to have to assign something to Celsius, which is going to be, just like this code right here. So if I know this function is calculating something, performing a return statement, make sure that you return it immediately and then write the implementation. Okay. All right, so that's the introduction to functions. We'll talk some more about some of the other details, some of the nice to haves, but this should be able to get you going on all of the labs and the assignment.